Sequences are simply a list of numbers that follow a set pattern. We have a more formal definition coming up in a second, but you've dealt with these patterns since you were probably in elementary school, where you had a list of numbers and they would try to get you to figure out, what's going to come next. Are they adding 3 every time? Or are they adding 3, then 4, then 5, then 6? Or are they multiplying by 2, then adding 1, multiplying by 2, then adding 1? Those kind of patterns are really just sequences. So let's look at a more formal definition. A sequence is a function whose domain is the set of natural numbers. If you remember, natural numbers are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So essentially it's the positive integers. So you can't plug in 1.5 or 3.1, and you also can't plug in negatives. Now technically they say the natural numbers, but they sometimes use 0. And 0 is actually part of the whole number set, but not the natural number set. So this is the definition our book gives, so I'm going to stick with it, but sometimes 0 shows up as well as part of the domain, just to let you know. So just a couple quick examples. 1, 2, 4, 8, you can see there they're simply multiplying by 2 each time. 1, negative 2, 3, negative 4. You can see that we're going up by 1 each time, but we're also changing our sign each time. So it goes positive 1, negative 2, positive 3, negative 4. Then the one over there on the right, it says 1, 1, 2, 3, 5, 8, 13. Is actually a very special and very famous sequence called the Fibonacci sequence. If you ever heard of the golden ratio, this is related to that. This is found in nature a lot, believe it or not. But here, the way you do it is you take the previous two terms and you add them together to get the next term. For example, 1 plus 1 gives you 2. 1 plus 2 gives you 3. 2 plus 3 gives you 5. 3 plus 5 gives you 8. 5 plus 8 gives you 13, and so on. So those are just some examples of sequences. Okay, here's some notation. Remember, notation just means how we write things. If you see these squiggly brackets, that just represents the whole sequence, whereas without the brackets, it often will just represent a single term. So AN means the nth term. So for example, A3 means the third term. If I do an A sub 4, that's the fourth term. Okay, the first term in a sequence can be a 1, which we would call the first term, or a 0, which we would call the 0th term. It is more often a 1, but it does happen that they start with 0. So just make sure you're watchful as to what they say it starts with. Okay, and then two things you need to know how to do. Find a specific term. So if they give you an equation for a sequence and ask you to find a specific term, like find the 23rd term, all you do is plug in 23. So to find a specific term, plug the number in for n. So if they ask you to find the third term, you plug in 3. If they ask you to find the fifth term, you plug in 5. If they ask you to plug in the ninth term, you plug in 9, and so on. The other thing you will be asked to do is just find the first 5 terms. So you may be asked to say, what's the first 5 terms of this sequence? And if you are, you just plug in 1, 2, 3, 4, 5, and get those answers separately. A really simple way to do that, if you're able to use your calculator on the problem, is to plug the sequence in y equals, and then go to your table and just plug in 1, 2, 3, 4, 5, and that'll give you the answers real quickly. So that's the first two things I want to make sure you know how to do, so we'll start with that. Find the first 5 terms for the sequence AN equals 3 to the n. So the first 5 terms. This one we'll just do by hand. First 5 terms we would get 3 to the first, which is 3, 3 squared, 3 cubed, 3 to the fourth, 3 to the fifth. Because if you notice, I'm just plugging in 1, then I'm plugging in 2, then I'm plugging in 3, then I'm plugging in 4, then I'm plugging in 5. And so my answer would be 3, 9, 27, 81, 243. So those would be the first 5 terms of my sequence. And all I did to get those was plug in 1, then 2, then 3, then 4, then 5. Okay, here's one that says find the 12th term. That's what A12 means. The 12th term for AN equals 4n over n plus 1. So there all I need to do is plug in 12 for n. 4 times 12 over 12 plus 1. So that's 48 over 13. That would be my 12th term. One thing I meant to say earlier, the domain is the set of natural numbers. So what I'm allowed to plug in is just the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. But my range, my output can be anything. Okay, so if you plug in a number and you get a negative, that's fine. Or if you plug in a number and you get a fraction or a decimal, that's fine. Your y values, your output, can be anything. It's just your input, what you plug in, can only be the natural numbers. Okay, one more example with this. Find the first 5 terms for a(n) equals 3 plus negative 1 to the n. So let me show you what I'm talking about with the calculator for this one. If you go to y equals, you can plug in your equation. 3 plus parentheses negative 1 raised to the n. Then you go to your table, and you can just plug in the first 5. 1, 2, 3, 4, 5. And that gives you the terms. It's 2, 4, 2, 4, 2. And that's the first 5 terms. So the calculator is a really simple way you can do the first 5 terms. Just plug it in y equals, go to your table, plug in 1, 2, 3, 4, 5. Now the reason this does this is if you think about when we plug in these numbers. So 3 plus negative 1 to the first. Well, negative 1 to the first is negative 1. So you get 3 plus negative 1, which is 2. But if you do 3 plus negative 1 squared, negative 1 squared is positive 1, so you end up with 4. Anytime that exponent is odd, it's going to stay negative 1. Anytime it's even, it's going to become positive 1. So all this does is alternate back and forth between negative 1 and positive 1, which makes the sequence alternate between 2 and 4, 2 and 4, 2 and 4. Anytime you see a negative number raised to the n, that's probably a good hint that you're going to have something that's alternating in some way.